Let's simplify this trigonometric expression. Right, we have to know where the marks are coming from. The marks are going to come from each component of the expression because we have to do something, okay? So I want us to discuss these components before we simplify our expression. Right, let's go there. Right, we have the first one here, which is 180 tan 180 degrees minus x. So this one, what are we going to do? We're going to do a reduction here. So where is 180 degrees minus x? It is in the second quadrant. 180 degrees minus x is in the second quadrant. And remember our cast diagram. Right, in the second quadrant, it is the sign of the angle that is what? That is positive. Otherwise, the tangent of the angle, the tan angle here is going to be negative in the second quadrant. It's going to be negative in the second quadrant. So it means we're going to have what? A negative tan x. Okay, we're getting our mark there. Right, we go to the second component, which is 360 cos 360 degrees minus x. Where is this angle? It is in the fourth quadrant. So 360 degrees minus x. So it is in the fourth quadrant, and then cosine of the angle there in the fourth quadrant is positive. Cosine there is going to be positive, and then it's going to be positive. So this is going to be cos x. It's another mark. You see that? Okay. And then we go to this type of angle. Right. So what we have there, we have sine 540 degrees plus x. So again, it's reduction, but we're looking at the angles of the form k times 360 plus theta. So we're saying that, let me use the sine this angle. So it's going to be sine k times 360 degrees plus theta. Okay, this is equal to sine theta. Okay, just know that. Right, now, so let me use the 540, and then I'm going to give you another example with bigger one, maybe say 900. So 540 is going to be how many 360s can get into 540? It's just one, and then a remainder. So it's going to be sine 1 times k. I didn't explain what k is. K is a positive integer. It can be 1, 2, 3, like that, positive integer. Right, and then 1 times 360 degrees, and then which is 360. Then what we add to 360 to get to 540? We have to get 180. Okay, plus 180 degrees. Okay, this is now 540, and then plus theta. Okay, right, but remember we said that sine k times 360 plus theta is equals to sine theta. So this is equivalent to the sine theta. So it means this is equals to sine 180 plus theta. Okay, like this. So the other way you can interpret this is using even the Cartesian plane. So if you check here, 540 will have the first revolution, which is 360, like that, up to here. See, we have 360 degrees, and then and then if you say 540 degrees minus 360, you are remaining with what? With 180. You see, okay, 180 to get to 540. You see that? And then we have 180 plus x, because it says plus x here. You see that? And then it means it's in the third quadrant. You see? Okay, so here that's why this is equivalent to sine 180 plus theta. Okay, whichever way you can use this or use the diagram. If you understand the diagram is fine, you can use it. If you understand this, what I've explained here, also you can use that. Right, let's use another angle and another maybe trigonometric ratio. Let's say we have cos 900 degrees minus theta. Okay, right? If you check here, if you say how many 360s, complete 360s can get into 900, there'll be two of them, isn't it? So this is going to be cos 2 times 360, which is 720, isn't it? And then 720 plus 180, so it's going to be plus 180. You see that? So this whole thing here is 900 degrees. You see that? It's 900 degrees, and then minus theta. Okay? But remember, we said what? We said like, if it's cos k 360 degrees plus theta, this is equivalent to cos theta. So now it means here we have this thing similar to k 360 plus theta. What is equivalent to theta now is 180 minus theta here, 180 degrees minus theta. So it's going to be cos this. Okay, this, let me just indicate here, is going to be equivalent to cos 180 degrees minus theta. Okay, you see that? Okay, right. Now, so this is the part there. So we're saying this will be equivalent to sine 180 degrees plus x, which is in the third quadrant, Right, we go to the next concept, okay, which is this. And then what do you think of here? These are negative angles. Remember, negative angles. Remember that cos negative x is equal to cos x. Then tan negative x is equal to negative tan x. And then sine negative x is equal to negative sine x. Okay, remember that. So that's what we have there. And then the last one, these are complementary angles. Remember, complementary angles. Okay, so cos 90 minus x is sine x. Just remember this. Remember, let me just write the four of them. Sine 90 minus x is equal to cos x. And then sine 90 plus x is equal to cos x. And then cos 90, let me write the degrees. Cos 90 degrees minus x is equal to sine x. And then we have cos 90 degrees plus x. This is the only thing that will give you negative. So this is negative sine x. Okay, just remember this. So we're talking about this one here, so it means this is going to be sine x. So now this is where the marks are coming from. Okay, and then let's just do everything together now. So what can we do now? We've discussed everything. So tan 180, I said in the second quadrant, this is going to be negative tan x. So it's negative tan x. And let's protect our things using brackets like this. And then we go to the second one, cos 360 degrees minus x is in the fourth quadrant, and cos is positive there. So it's cos x. And then plus. And then we say this is equivalent to sine x. This is equivalent to sine 180 degrees plus x. So it means it is in the third quadrant. So it's going to be negative sine x. Okay. And then we're done with the numerator. We come to the denominator. Okay, complementary angles there. And this is sine x. This is sine x. Sine x. Right, and then negative angles, cos x is cos x. You see that? Okay, and then what do we do after that? Remember, our identity, tan x is equal to what? Sine x over cos x. So let's change that. It becomes negative sine x over cos x. Okay, all right, to make our life easier, let's write this cos x as what? As cos x over 1, so that you can clearly see what you're supposed to do there. then minus, because positive times negative is negative, so it's going to be negative sine x. So you see the importance of brackets, okay? And then this is sine x cos x. Okay, and then here you can say cos x divided by cos x is what? Is 1. So we're remaining with what? Negative sine x minus sine x divided by sine x times cos x. Okay, and then what is negative sine x minus sine x is going to be negative 2 sine x over sine x times cos x. Then sine x divided by sine x is 1. We're remaining with negative 2 over cos x. We've simplified our expression. Okay, let's meet when we do our next question.